In this video, I'm going to look at some of the options that you've got on your graphical calculator for differentiation questions. I've picked a fairly basic one, but you could do this for any questions involving trig or anything more complicated, but remember, trig questions must be in radians. So, the first part of this question gives us our function and asks us to find the value of dy over dx when x is 2. The calculator cannot do any of the algebra for you, it can only tell you the final numerical solution. So I could do this in mode 1, and if I go to F4, which is math, you can see that we've got two differential options. F4 is the first derivative and F5 is the second derivative. This question I just want the first derivative, so I can press that. Comes up with a nice box, so in this box you type in the original function. So I've got 2x cubed and then minus 2x plus 1. Then once you've typed in the function, press across so it takes you to the x box, type in x equals 2 and press execute. So it tells me that dy dx is equal to 22 when x is equal to 2. Remember, you must show you're working out, you must show you've differentiated it. This is just to check your solution. Now, if you want to do a bit more, so finding tangents and stationary points, you're best to be in the graph mode, which is number 5. Now, the standard setting, if you've not changed it, is for differentiation to be turned off. So you need to go to Shift and Setup and go to Derivative and turn it on. Once you've done this once, it should just stay on. So, again, I want to type in my original function. So 2x cubed minus 2x plus 1. And it will sketch my graph for me. Can't see at the moment, so I'm going to go to V window to check the axes, and I'm just going to go for standard, or I could input my own. If I click standard, I've got a better bit of the graph. It might be that I want to zoom in, so I can zoom into the centre if I want to see that bit a bit clearer. So, equation of the tangent then, that is in the sketch option, which is F4. So if I click on F4, it comes up with these options. I've got tangent and normal. So you do both these the same way. If I click on tangent, it comes up with this on the graph. Now it tells me that at the moment x is 0 and y is 1, and the derivative will be minus 2. I can just move across the graph if I want, using the arrows, and it will tell me the different values. I could, as before, type in x is 2. Now it doesn't prompt you to do this, you just have to know that if you press 2, it will come up with an x screen. And here we can see again that dy dx is 22, which is what we've already checked. This question though, I want when x is 1. So I'm going to press 1. And press execute. It tells me that dy dx is 4, so you might need to check that you've got this correct. If I press execute again, and again it doesn't prompt you to do this, it will draw the tangent on for me and tell me what the equation of the line should be once I've rearranged it. So it always gives it you in this particular form. So my equation of my tangent when x is equal to 1 would be 4x minus 3. Again, this is just a way of checking. Now that tangent will stay there. If you do want to get rid of it, if you just press exit and move on the graph a little bit, it will disappear. The other bit you might want to know is the coordinates of any stationary points. Now remember, stationary points are just the minimums and maximum points of the graph. So in GSolve, which is F5, if I press maximum, then it tells me that my coordinates are minus 0.573. And that my y is 1.769 and so on. It's more likely that you'll get exact answers, or the question might be asking for exact ones, so you might need to just check that these are the same. Remember, you must show you're working out. If I go back to GSolve, I can do the same for minimum, and it will also give me the coordinates of the minimum point. And I can check that these are the same as I've got. You mustn't just write down the answer without any working out. You must show the method you've done. This would work for any of the different functions. Again, remember, if it's trig, you must be in radians.